All right, hello everyone, welcome to this video. This is a conceptual problem involving the ideal gas law in which you have one constant and then the other variables changing. So let's just write down the ideal gas law 1 second. PV is equal to NKT. And essentially what we want to know here is if one of these variables is held constant and then the other three are made to change, of the ones that are changing, if we know how two of them are changing, can we predict how the third one must change in order to keep the system in equilibrium? So let's go through an example. Let's imagine that the number of moles, n, or in this case, sorry, the number of molecules, n, is going to be our constant. And of course, k is also a constant, so we could divide both sides and do PV over T is equal to NK. And now, since these two variables are all going to be constant, then we know that whatever values PV and T have before, it must also equal what PV and T will have after, as long as they're multiplied together and divided in this ratio of PV over T. So we get PV over T equals PV over T. I'll just write that one more time to emphasize it. And so the way that, the kind of problem that you could expect for this is, let's say I told you that pressure 2 is equal to some multiple of pressure 1. So pressure 2 is going to be A times pressure 1, and let's say volume 2 is going to be B times volume 1. So maybe this A is like 2 and this is 3 or something like that, to some number. And then we would want to know for if T2 was going to be some value of C times T1, the question could ask you, what does C have to be so that the system will stay in equilibrium, considering that A and B are the factors that are changing the initial pressure and volume? So that's it in an abstract form. Well, let me just give you like concrete numbers for a second. So let's say P2 is equal to 2 times P1. Let's say V2 is equal to 3 times V1. And the question is saying, what do you have to multiply T1 by to keep the system in equilibrium? So we could come back over and we could say we're going to have P1 V1 over T1 is equal to P2, but now instead of P2, I'm going to put 2 times P1. Instead of V2, I'm going to put 3 times V1. And instead of T2, I'm going to put like my unknown, I'm calling it C, times T1. And so the question is, what is C? And you can see here in the numerator, I have 2 times 3 is 6, so C is going to have to also be 6. So that basically the 6 in the numerator and this C value of 6 will cancel out, and I'll end up just having an equality. PV over T is PV over T. So the answer here is that C would be equal to 6, and then that means that temperature 2 is 6 times whatever temperature 1 would have to be in this case. So if we've doubled the pressure and we've tripled the volume, we're going to have to multiply the temperature by 6 in order to keep the system in equilibrium. So you can practice this technique with different sets of variables held constant. So you can imagine going back up and saying, let's say we're going to keep temperature constant instead of number of molecules. If temperature is constant, then I would do PV over N is equal to KT, which is PV over N, where these are all 1s and these are all 2s. And so now you can play the game again. You can change pressure and volume and N by whatever factors A, B, and C you want, and then try to figure out what would the C value be to balance the factors of A and B. Notice that it's not always going to be just A times B. For example, if I multiplied this one by A and I multiplied this one by B, and the C was getting multiplied in V2, then the C is going to end up being B over A instead of just A times B like it was before. So make sure, guys, that you don't just memorize the exact example I did here. Make sure you got the concept so that when you get your problem, you figure out which value is being held constant, set up the expression of the other three in this, like the 1 states and the 2 states, and then interpret from the problem which of the variables are getting multiplied by factors and which is the factor that you're trying to actually find. Okay, so that's ideal gas law, conceptual scenario with one constant. Thank you so much for watching, and I'll see you in the next video.